Imagine for a moment you're standing on the moon, surrounded by the vastness of space. Suddenly your spacesuit vanishes. What happens next? This is no ordinary daydream, but a hypothetical scenario that will lead us into the depths of the moon's harsh environment. It's a place that's simultaneously as beautiful as it is deadly, a dance of light and shadows on a surface bereft of life as we know it. The moon, our closest celestial neighbor, is a world apart from the familiar landscapes of Earth. Here, the air we breathe is non-existent. Yes, you heard it right. The moon lacks an atmosphere. An atmosphere, that protective blanket of gases that shields us from the harsh realities of space, is absent here. This lack of atmosphere is not just a minor inconvenience, it fundamentally alters the conditions on the moon's surface. There are no winds to carry away your voice, no air to breathe, and nothing to buffer you from the searing heat or the chilling cold. And speaking of temperatures, the moon is a place of extremes. When bathed in sunlight, the lunar surface can reach a scorching 123 degrees Celsius. But in the shadow of a lunar mountain or during the long lunar night, temperatures can plummet to a frigid negative 173 degrees Celsius. So we've set the stage. You're standing there on the moon with no spacesuit, no atmosphere, and exposed to extreme temperatures. It's a scenario that's as terrifying as it is fascinating. But we're not done yet. There are more factors at play here, factors that are invisible to the naked eye, but nonetheless deadly. We'll explore these in the coming segments. For now, let's pause and reflect on this unthinkable scenario. The moon, a place of desolate beauty, a world that's simultaneously close yet so far away from the comfortable confines of Earth. Now let's delve into the immediate effects on the human body the moment the spacesuit is removed. The moment your spacesuit disappears, things begin to happen, and they happen quickly. Let's start with decompression sickness, also known as the bends. This condition occurs when a person experiences a rapid decrease in the pressure that surrounds them. In the vacuum of space, this change is instantaneous. As the pressure drops to nearly zero, the gases dissolved in your body fluids would rapidly expand. This leads to gas bubbles forming in your blood and soft tissues, causing severe pain and potentially damage to your body organs. But that's not the only problem. You'll also have to contend with a lack of oxygen. As your body uses up the existing oxygen, you won't be able to replenish it. This lack of oxygen or hypoxia would quickly lead to unconsciousness. It's a race against time, and unfortunately time is not on your side. And in approximately 15 seconds, your body would use up all the oxygen in your lungs and bloodstream. Now let's discuss the vacuum of space. Exposure to this vacuum would have immediate and devastating effects without atmospheric pressure to hold your body together. Your blood would start to boil at body temperature. The saliva on your tongue would evaporate almost instantly. Your eardrums and capillaries might rupture due to the drastic pressure difference. But remember, all these effects are happening simultaneously. Your body is being assaulted on all fronts. The lack of oxygen, the bubbles in your blood, the boiling fluids, the rupturing tissues, ... It quote S, a cascade of catastrophic events. And here's the chilling part. Despite all this, you wouldn't just drop dead instantly. Instead, you'd likely remain conscious for those initial 15 seconds, experiencing the terrifying effects before darkness takes over. But that's just the beginning. Let's delve deeper into the effects. Without a spacesuit, you are exposed to the extreme temperatures of the moon. But how extreme are we talking? Let's delve into that. The moon, unlike Earth, lacks an atmosphere to regulate its temperature. This means, depending on whether you're in the sunlight or in the shadow, temperatures can swing wildly. In the full glare of the sun, the lunar surface can sizzle at around 250 degrees Fahrenheit. That's hotter than a home oven set to its maximum temperature. It's enough to melt lead or even boil water right out of your body. On the flip side, in the moon's shadow, temperatures can drop to a bone-chilling negative 250 degrees Fahrenheit. Now, that's colder than the coldest temperature ever recorded on Earth. It's so cold that any exposed skin would freeze instantly. So how would the human body respond to these extreme temperatures? In the blistering heat, your body would try to cool down by sweating. But with no air to evaporate the sweat, it would just pool on your skin, doing little to cool you down. Over time, the heat would start to cook your body from the inside out. In the frigid cold, the exact opposite would happen. Your body would start to shiver in an attempt to generate heat, but without an atmosphere to hold in that heat, it would be lost to the void of space. Your body would quickly succumb to hypothermia, freezing from the outside in. But let's not forget, these temperature extremes would only be part of your worries. The rapid change from extreme heat to extreme cold would also cause your body to undergo thermal shock, resulting in potential organ failure and ultimately death. So, extreme cold and extreme heat, but there's another danger lurking: radiation. Our tale of lunar peril doesn't end here, though. Stay tuned as we delve deeper into the invisible threats that await anyone daring enough to venture onto the moon without protection. In the absence of a spacesuit, your body is exposed to the full brunt of cosmic radiation, but what does this actually mean? Well, think of cosmic radiation like a hailstorm, a relentless bombardment of high-energy particles from the sun and beyond our solar system. Unlike on Earth, where our magnetic field and atmosphere shield us, on the moon there's no such protection. These tiny particles, invisible to the naked eye, are packing quite a punch. They are moving at nearly the speed of light, and when they collide with the atoms in your body, they can cause serious damage. This is where things get a bit cellular, so bear with me. Your body is made up of trillions of cells, each with a nucleus that contains your DNA, the blueprint for your body. Now, when these high-energy particles strike, they can break the chemical bonds in your DNA. This can lead to mutations, which can disrupt normal cell function. The effects can range from minor issues like fatigue and nausea to more serious conditions like cataracts, cancer, and degenerative diseases. It's a bit like playing Russian roulette with your cells. The more you're exposed, the more likely you are to experience these effects. Of course, the degree of damage depends on the duration of exposure. A brief moonwalk might not be immediately lethal, but over time, without protection, the cumulative effect of this radiation can be devastating. So it's not just the lack of air or the extreme temperatures that make the moon a hostile environment for humans. The invisible threat of cosmic radiation is a silent yet potent danger. In essence, cosmic radiation is like a ticking time bomb. Without a spacesuit, your body is essentially a sitting duck, subject to a barrage of high-energy particles that can wreak havoc on a cellular level. So, as you can see, being on the moon without a spacesuit is a deadly proposition, but let's summarize what we've learned. So, we've taken a hypothetical journey to the moon without a spacesuit. Let's review what we've learned. Our journey began with the unthinkable scenario: stepping onto the lunar surface without the protective shield of a spacesuit. We soon discovered how our bodies would react to the sudden vacuum of space. Within 15 seconds, the lack of oxygen would cause us to lose consciousness. Within 2 minutes, we'd meet an untimely end due to asphyxiation. Then we delved into the immediate effects of exposure to the lunar environment. The low pressure would cause our bodily fluids to boil at body temperature, leading to a condition known as ebullism. Simultaneously, the lack of atmospheric pressure could cause our bodies to swell, a phenomenon referred to as the bends. Next, we ventured into the extreme temperatures of the moon. The intense heat during the lunar day, reaching up to 250 degrees Fahrenheit, would scorch our skin, while the chilling lunar night, plummeting to minus 250 degrees, would freeze us stiff. The absence of an atmosphere to regulate temperature means these extremes would be felt almost instantaneously. We also touched on the invisible threat: radiation. Without the Earth's magnetic field and atmosphere to shield us, cosmic rays would bombard our bodies, causing serious damage to our cells and DNA, leading to severe illnesses like cancer. In summary, venturing onto the moon without a spacesuit would expose us to a cascade of lethal conditions. From oxygen deprivation to temperature extremes, pressure changes to radiation exposure, each factor presents a formidable challenge to human survival. As we've seen, the moon is a harsh and unforgiving environment. Without a spacesuit, survival is, simply put, impossible. So the next time you look up at the moon, remember the incredible technology and preparation it takes to explore our nearest celestial neighbor.